Hi again, and welcome back. We are going to be focusing today on solving systems of linear equations again, but this time, instead of using substitution, which is the method that you saw previously, we're going to use another algebraic system called elimination. And it's along the same lines where we're going to eliminate one of the two letters, either x or y, in both equations, leaving us only with one variable left behind to solve for. So basically, we have to first decide which variable we want to eliminate. And there's no right or wrong answer, just that there's some that are easier to do than others given each equation. And I'll explain to you what I mean by that when we do our examples. But in order to eliminate a variable, your goal is to have the same numerical coefficient. So the number in front has to match. So whatever number's in front of the x in one equation has to be the same number in front of that x in the second equation. And if they're not the same, you have to multiply one of the equations or both of the equations by another number that makes them both match. And I'll show you what I mean by that. So once you get them to match, so the x's match or the y's match, you then have to decide, are you going to add or subtract the equations to eliminate that variable? So for instance, if the signs are the same, so we have negative 3x in one equation and negative 3x in the second equation, what you're going to do between those equations is you're going to subtract. So if the signs are the same, subtract. So same sign, subtract both equations from each other. And that means you subtract everything, not just the x's, but you also subtract the y's from the y's and the constants from the constants. If the signs happen to be different, so you have a negative number in front of the x, and then in the second equation you have the positive version of that number in front of the x. So they still match, it's just that one's plus and one's minus. In order to get them to become zero, which is what we mean by eliminate, you want them to total zero, you're going to add. So if they're opposite signs, you're going to add between both equations. And again, you're adding the x's with the x's, the y's with the y's, and the constants with the constants. So let's look at this first example here. So solve each system of equations, and that the way that they're set up, you see how they're set up in standard form with the x's and y's on one side and the constant by itself on the other side. It's already set up in order to do elimination. You wouldn't rearrange this and do substitution. That would be very, very difficult because you'd be left with a lot of fractions, right? You try to isolate for the x, you'd have to divide by 7. If you try to isolate for the y, you'd have to divide by 4. So it's not set up for substitution. It's definitely set up more for elimination. You see how the x's are on top of the x's, the y's are on top of the y's, the equal signs on top of the equal sign, and the constants on top of the constant. That's what you want. You want to line up everything vertically so it matches. And then you want to look. Right here I have 7 x's and here I have 6 x's. Right now they're not the same number. I don't have the same amount. I need to get them to match. So either I can times this first equation by 6 and the second equation by 7 in order to get 42 x's, which is fine. Or if I look at the y's here, I have 4 y's here and 2 y's here. Now again, they don't match. So I would say, why don't we times the second equation by 2? That would change this 2y to 4y in order to get them to match. I don't have to then do anything to the first equation because it already has the 4 in front of the y, so it already does match. So the way I would get you to show that on paper is that you see that they're already numbered, equation 1 and equation 2 with those little circles. You can just go times 2 right there next to it. So that means you're taking that first equation and you're multiplying through by the number 2. So the first part gets times by 2, the second part gets times by 2, the last part gets times by 2. So what does that look like? So again, I'm just going to recopy the first equation. So that was equation 1, hasn't changed. The second equation is now going to look like 12x plus 4y equals 8 times 2, 16. So that's my new equation 2. You can also call that equation 3 if you want. It doesn't really matter if you rename it something else. It's just a different version of equation 2. Then you're going to draw a big line underneath, like you did in elementary school when you did addition and subtraction. So right now we have the y's matching. That's what we wanted. We don't care that the x's match. We just aim for one variable to match. Now you see how the first y has a minus sign in front and the second y has a positive sign in front of the 4. Those are opposites. So if the signs are opposites, what we do is we add between the different equations, and that's what's going to make them go away. So watch this. 7x plus 12x's gives me a total of 19x's. Negative 4y plus 4 more y's gives me 0y. So you don't have to write 0y. We just don't write anything down because they went away. We don't have any. And then on the other side of the equal sign, 3 plus 16 is 19. This is a very nice now simple equation, 19x equals 19, that allows you now to solve for the remaining variable that's left over, in this case x. In order to get x alone, you divide by the coefficient in front of the x, which is 19, to make those go away, to give you 1x. 19 divided by 19 on the other side is 1. So we got the x coordinate of the POI, the point of intersection. So let's go back now. Let's do elimination again. So at this point, you have the option of doing elimination all over again from the start, but this time, instead of making the x's match, we're going to make, or the y's match, we're going to make the x's match. So again, what we would have is 7x minus 4y equals 3. That was equation 1. 6x plus 2y equals 8. That was equation 2. Now I want to get the x's to match. So what's the first number we know that both 7 and 6 go into? Well, if you're not sure, you can start counting by 6's, and you can stop when you get to a number that 7 also fits in. So 6, 12, 18, 24, 30, 36, 42. So 42 is the first number that both of these coefficients can become. So it's like your lowest common multiple, right? As if we were getting a common denominator here. Well, in order to get this to be a 42, it's a 7. We have to times it by 6. In order to get the 6 to become a 42, we have to times it by 7. So what we're going to do is we're going to multiply everything in the first equation by 6, which becomes 42x's minus 24y's equals 18. And again, that's another version of equation 1. Now you can call that equation 3 or 4 or whatever it is that you're up to. It really doesn't matter. 7 times 6 is 42. See how they match? 7 times 2 is 14. So we have positive 14y's. And 7 times 8 is 56. So that's equation 2. I'm going to draw, again, a big fat line underneath. Now, again, the 42's are what are matching, right? The x's match, not the y's this time. So what we need to do is we need to figure out if we're adding or subtracting. We have positive and positive. Those are the same sign. So in order to get 42 and 42 to give you 0, we have to subtract. So put a big fat negative sign in front. 42 subtract 42 is 0. Negative 24 minus 14. Negative 24 minus 14 is negative 38. 18 minus 56. 18 minus 56 gives you your negative 38 on the other side. So again, notice we have a nice simple equation that doesn't have x's in it, only y's, which is what we want. Now we can isolate minus 38 minus 38. 38's go away, the negative goes away, giving us positive y on one side and positive 1 on the other side. So therefore, the point of intersection, or the solution to the system, is 1 for the x, 1 for the y, 1, 1. That's where these two lines happen to intersect at 1, 1. So you can see that we just did elimination back to back. And it's not a lot of work, obviously. It's not a lot of writing, I should say. But some people, after they do elimination the first time to get the first number, either for x or y, what they want to do is they want to combine it with substitution. So they're going to take this number of 1. Now you have to hope that this number is correct because your next answer is going to now be based on this answer. So unlike doing elimination twice where this answer could be right and this one could be wrong, this one is now going to be used in order to replace the letter x either in equation 1 or equation 2 in order to solve for y. So what would that look like? So we're going to substitute x equals 1, for instance, in equation 1. It doesn't matter which one you use to get y. So what we're going to do is 7 times x becomes 7 times 1 minus 4y equals 3. So that's 7 minus 4y equals 3. Negative 4y equals 3 minus 7 when you bring the 7 to the other side. Negative 4y equals negative 4. Divide both sides by negative 4. Y equals 1. So again, you see that we get to the same answer in the end for the POI, 1, 1. It was just a different way of doing it. So this is elimination first combined with substitution. And both are obviously correct. You just have to decide which one you like better. If the question says use elimination back to back, then it means you're doing option 1 here, where you're eliminating for the first variable and eliminating again for the second variable. So again, let's try that in the second case over here, where again it's set up for elimination because we have the x's on top of the x's, the y's on top of the y's, and the constant on top of the constant after the equal sign. Notice how the x's don't match, the y's don't match. So right now they're not set up right now perfectly, so we have to get them to match. So either the 8 and the 5 can become the same common number, which would be 40, or the 4 and the 3 become the first common number, which would be 12. It really doesn't matter which one you go for. It's the same thing. So let's get the y's to match again. Why not? Times the first equation by 3 times the second equation by 4. So what happens is 8 times 3, that becomes 24x's minus 12y's equals 48. And then we times the second equation by 4, which is 20x's minus 12y's equals 4 times 11, 44. Draw a big fat line. Now your big decision. Are you going to add or subtract these equations in order to get the y's to go away? Right now we have negative 12 in front of this y and negative 12 in front of that y. Negative and negative, same sign. In order to get the same signs to go away, we actually subtract both equations from each other, which means 24 minus 20 of the same thing gives me 4 of those things. Negative 12, take away negative 12 is negative 12 plus 12, which is 0 y's. I don't have to write those down. Write down your equal sign. 48 minus 44 is 4. Divide by 4, divide by 4, x equals 1 again. Wow, very common. Now we have this first answer. Let's do elimination again. In order to get the second answer, I'm not going to do substitution. I'm going to just do elimination back to back. So again, 8x minus 4y equals 16. 5x minus 3y equals 11. We're going to times the first one by 5, and we're going to times the second one by 8. So the first equation is now going to become 40x minus 20y equals 16 times 5, looks like 80 to me. Then we're going to times the second equation through by 8 to get 40x again, minus 24y's, and 8 times 11 is 88. So that's my new equation 1, my new equation 2. And again, you can call them 3 and 4. We're going to get these 40's to go away since they match. So we're going to put a big fat minus sign. That becomes 0x's. Negative 20 plus. So negative 20, take away negative 24. So that's what you would type into your calculator. Negative 20, subtract negative 24. That's negative 20 plus 24, which would then be left with 4, right? So we have 4 in front of our y's, and 80 minus 88 leaves you with negative 8 on the other side. Divide by 4, divide by 4, y equals negative 2. So, therefore, the POI is x always goes first. It doesn't matter on the order you found them in. X is up here. 1, negative 2 is the solution to that system. So that was elimination back to back. Solve the following system using any method you wish. So it's not being specific here as to what it wants us to use. So we're free to use anything we want. Now this first one is ugly. So when we have fractions, which is what we have here, right? We have a quarter and a third and whatever. Most people don't like dealing with fractions, so we want to get rid of them. So by getting rid of them, what that means is get lowest common denominator. So by getting the lowest common denominator in each individual equation, so just the first equation, get the lowest common denominator, then we're just going to be working with numerators. Okay, so that's what we're going to do. We're going to remove the fractions. So we don't have to worry about changing them into anything else. And we're not going to do substitution here because it's going to look ugly when we have to divide by 3 or divide by 9, right, in order to get y equals. So in order to do that, let's look at the first equation. We have a 1/4, we have a 3/1, and we have a 1/2. In order to get them to match, I would suggest that you turn everything to on top of 4s, right? Because 4 is the common denominator, the lowest common denominator. So right now, the first coefficient is already on top of a 4. The second coefficient was on top of a 1, right? That's -3/1. So we have to times top and bottom by 4, which gives us -12. The second, or the last fraction, had a 2 on the bottom. In order to get it to be a 4, we have to times everything by 2, which gives us a 2 on the top and the bottom, 2 on the top. So because of that, because now everything's proportional on both sides of the equal sign, the 4s actually don't matter anymore because, again, proportionality exists. So what we deal with is just the numerators, which changes this into 1x minus 12y equals 2. So that's what this first equation now looks like. Nice and clean. X minus 12y equals 2. We're going to do the same thing to the second equation. You see here how the first coefficient is a third? The second coefficient is 9, which is 9/1, and the constant is 5, which is 5/1. The lowest common denominator between 3, 1, and 1 is going to be a 3. So we have to get them all to match, something with 3's on the bottom. I don't know why I did that there. So the 3 goes on the bottom here for the y, and on the other side, a 3. So the first one already came with a 3. So he'll just stay what he is because he already had a 3. The 9/1, we times top and bottom by 3, which changes it into -27 instead of -9. And then the last one came with a 1, so again we times it by 3, so 5 times 3 is 15. The 3's go away, which means we're left with 1x minus 27y equals 15. That is equation 2. So what's going to happen is, you see how we have a 1 in front of the x and a 1 in front of the x? That's already set up beautifully now for elimination. We don't care that the y's don't match. The x's match, and that's good enough. So because the x's match, we can just from right here draw our line. And now that I know I have positive 1x, in order to get them to go away, 1 minus 1, right? I'm going to subtract these equations to give me 0 x's. But I have to subtract everything else. -12 minus -27. -12 plus 27, right? Negative makes plus. So -12 plus 27 is, what am I looking at? I'm going to be left with 15. So -12 plus 27, you want to check that. We got 15y's, and 2 minus 15 gives me -13. So not a very nice equation here as far as numbers go. But what can you do? It is what it is. So now we're going to divide both sides by the 15, divide by 15, and that's what you get, -13/15 for y. So not a very clean number, but it is an answer. That is an answer. So, I mean, we can use it. It's not a problem. But that's to show you not all your answers are going to be 1, 2, 3, 4, 5, right? They're also going to be decimals and, in this case, fractions. Please leave your answers as fractions. They're more exact. Don't change this to a decimal. unless you were trying to figure out where to plot this. 13 divided by 15 is where you would look for it on your x and y axis. So 0.87, so negative 0.87. So negative 0.87 is approximately what it is. Let me move the approximate sign and the negative sign here. So negative 0.87 is approximately where you would find that point for y. But now we have to go back and do x. So the problem is our x's match already, but the y's don't match. And we have a 12 and a 27. And a 12 and a 27 don't easily become the same amount. So I don't think I would do elimination again. I would actually do substitution because I think it's going to be hard to make these two numbers match unless you times the first equation by 27 times the second equation by 12. So it's definitely doable. So we could do that, or you could substitute in for y up here in the first equation, 13 over 15. Totally doable as well. I'd say both are relatively the same amount of work. So why don't I do substitution now just to show you. So we're going to substitute negative 13 over 15 for y in equation 1. The reason why I'm using equation 1 is just lower numbers. So it looks like it might be a little easier for me. So we have x minus 12, and then instead of y, right, negative 13 over 15 equals 2. Okay, so that was equation 1. Top times top, bottom times bottom. I'm going to clean up these numbers a little bit. So 12 and 15, 3 goes into both, so I can cross reduce. So a 12 and a 15, like I said, 3 goes into 12 4 times, 3 goes into 15 5 times. So by doing that, this now becomes 4 times 13, which is 52. So that's positive 52 over 5 instead of some other huge number. Equals 2 on the other side. So again, we're going to kick this out to the other side to subtract 52 over 5. Now that 2 is on top of a 1. So we're going to times top and bottom over here by 5. So times top and bottom by 5, right, to get them to match 5. So times 5 gives us 10. 10 subtract 52 is negative 42 on top of a 5. And again, when you go into your calculator and you try to figure out the decimal here, that's approximately negative 8.4. So if you were looking for it on the grid, you would know where to go to plot your point. So remember to answer the question. Therefore, the solution to the system is x goes first, so it doesn't matter that we found y first. X is always listed first when you do your coordinates. X always x then y. So negative 2 over 5, negative 42, sorry, over 5, negative 13 over 15. So those are your exact answers for where these two lines happen to touch. So again, when you're given fractions as coefficients, I suggest you get rid of them by getting within each equation the lowest common denominator, and then you only work with the numerators that are left over in the equation, as long as everything is balanced on both sides of the equal sign. So you do that for each equation individually, and then from there you can do elimination and or substitution. Over here, when you see brackets, as you see in the next set of equations, they're not set up right now just to be eliminated or substituted. So when you see brackets, what you do is you multiply out. So we multiply out. So we're going to now distribute the 2 to the 2x minus 1 to give us 4x subtract 2. We're going to distribute the negative, so negative y, positive 4, and the 11 is just 11 all sitting by himself on the other side. So that's equation 1. We're going to clean this up because it doesn't look like very cleaned up right now. We have 4x sitting by himself minus y sitting by himself. 4 take away 2 is 2. Kick it out to the other side. It's going to become minus 2, which gives us 9. So there's the first equation cleaned up. Again, The 2 is going to go to the other side. The 4 is going to go to the other side. So when you do that, you're going to be left with 9. Do that to the second equation. So again, the 3 is going to multiply with the 1. The 3 is going to multiply with the negative x to give you 3 minus 3x, negative 2y, positive 6 equals negative 6. That's equation 2. What did I write here? 3 minus 3x, there we go, negative 2y, positive 6. So again, let's put the x's in the front like we always have, then the y's. Now 3 plus 6 is 9. Kick it out to the other side, it becomes minus 9, which is negative 15 then altogether. So we have this equation and we have this equation. So we have these two equations that can now be put together, and we can either do a substitution or elimination. So if we were looking at them on top of each other, this is what we have, right? If I lay them on top of each other, the x's don't match, the y's don't match. So we have to then multiply one or both equations in order to get them to match. Well, right now you can see that this y is 1y, this y is 2y's. It's easy to make 1 to become a 2. So this first equation, the second equation, we can just times the first equation by 2 very easily. And that's going to change it into 8x's minus 2y's and then 18 on the other side. So there's equation 1, right? Rewritten. You can call it equation 3 if you would like. And now what happens is the y's match. Negative, negative, same sign. So in order to get the same signs to go away, we subtract. Negative 3 minus 8 of the same thing is negative 11 of those things. Negative 2 plus 2 is 0. Negative 15 minus 18. So negative 15 minus 18. So make sure that you're not thinking about it the other way of 18 minus 15. It's negative 15 and then the subtract sign minus 18. So it's negative 33. Again, that's a nice little mini equation. Divide by negative 11, divide by negative 11. You're left with an x worth 3. So once you get to this point, again, you can go back and do elimination again. This time you can make the x's match. So again, we had 4x minus y equals 9 was our starting equation. Always back to the beginning. Negative 3x minus 2y equals negative 15 is our second equation. We're going to try and get the x's to match, which means we're going to times the first equation by 3 and the second equation by 4. So we're going to get 12x's minus 3y's equals 27. Negative 12x's. So when we times this one by 4, we times that one by 4, negative 8y's, and we times 15 by 4, negative 60. So here's our new equation 1 and our new equation 2, or 3 and 4 again. 12, take away 12. So what we're going to do is we're going to add these, because I don't want this sign to flip. So 12, take away 12 is 0. Negative 3, take away 8 more is negative 11. And 27, take away 60 gives us negative 33 again. So again, divide by negative 11, divide by negative 11. It looks very similar to what we had before, and we get positive 3. So therefore, the POI, the solution to the system is x always goes first, right? X comma y. X is 3. Y happens to be 3 as well. I was going to write y again. 3 comma 3. Now, if you didn't want to do elimination, when you got to this point up here and you had the equations all nice and expanded and cleaned up, you already had the y in a very good situation in order for substitution to work. You could have done substitution. So this is or, because it didn't tell us what method, right? So it said whatever method you want. A lot of people would have seen this first equation, right? Equation 1, and they would have said, I'm going to isolate for y, which means I would put the y on the other side, and then the 9 would have to kick out. So that's what it looks like when the y is sitting over here. He becomes positive, and the 9 sits back where the 4x is. He becomes negative. This chunk is what you're going to substitute. So substitute 4x minus 9 for y in equation 2. So remember, we've already used equation 1 to isolate. We then have to use the other equation that we haven't touched yet to replace y. So negative 3x minus 2 times, instead of y, we're going to now replace it with 4x minus 9. And then that's what gives us minus 15 on the other side. So again, distribute. Negative 8x's, positive 18 equals negative 15. Clean up your numbers and clean up your x's. So negative 3x minus 8x is negative 11x. Negative 15 minus 18. So negative 11x equals negative, again, 33. Look at that. Negative 11, negative 11. X equals 3. So again, we got what we got, either doing elimination or substitution, showing you that it wouldn't matter. Then from here, you would sub 3 for x, and then you could use this nice cleaned up equation, y equals 4x minus 9, because it's already set in terms of y equals, which is what we want. Y equals 4 times 3 minus 9. Y equals 12 minus 9. Y equals 3. So you end up with 3 comma 3, like we did before, to show you that elimination back-to-back works, substitution back-to-back works, or a combination thereof. All right, so last situation here, we have a word problem. And in this word problem, we're going to probably use elimination, I'm guessing, because it looks like it might be a mixture question. So mixture questions are very custom in when it comes to linear systems, where we have a little bit of this and a little bit of that mixing together. So let's see. Every day at her bakery, Brenna bakes chocolate chip cookies and oatmeal cookies. So we have two different types of cookies here. She uses different amounts of butter and oatmeal in each recipe. Each batch of chocolate chip cookies uses 13 kilos of butter and 8 kilos of oatmeal, while each batch of oatmeal cookies uses 2 kilos of butter and 29 kilos of oatmeal. So we have different amounts of butter and oatmeal happening for these two different types of cookies. So each type of cookie gets its own equation. And then within each equation, you have an x and you have a y. The x is going to be the amount of butter. The y is going to be the amount of oatmeal. And if she has a total of 47 kilos of butter and 140 kilos of oatmeal, how many batches of each type of cookie does she bake? All right. So we're going to have to set up our two equations, which is what we do when we have these mixture questions. So I'm referring to this as a mixture question because we're having a little bit of each. And usually the last sentence tells you what your variables represent. How many batches of each type of cookies does she bake? Well, I don't know about that, but every day at her bakery, she bakes chocolate chip cookies and oatmeal cookies. She uses different amounts of butter and oatmeal in each. Each batch of chocolate chip cookies uses 13 kilos of butter and 8 kilos of oatmeal. Okay, so we're going to let x represent the amount of butter. I guess that's in kilograms. Let y represent the amount of oatmeal in kilograms.